L-shaped blocks and straight blocks require different approaches. Since a straight block lies within a single row or column, every number must be unique. Conversely, an L-shaped block spans multiple rows and columns, allowing the same number to appear twice. Allow the child to discover this distinction on their own. In a 4x4 grid, if the sum of a 3-box block is 11, the only possible combination is 4, 4, and 3. If the sum is 4, it must be 1, 1, and 2. Because a number repeats, the exact placement of each number is determined at once. By introducing the term a sure block, help the child recognize this as a definitive single clue. Take a close look and find a clue.
The 5-box block that makes 11 is a clue. If we look at what the block makes and what the line makes, we can narrow down the numbers.
Tell me your answer, and make sure to use the word because to explain why.
1, 3 is 1. Because the whole 5-box block makes 11, and the 4 boxes in column 4 inside it make 10. So, 11 minus 10 is 1.
Excellent! Shall we look for another clue?
We still have a 3-box block that makes 11, and a block that makes 4. I'll look at them one by one, and then try putting them together.
Go for it.
If I put the 2 blocks together, they make a 6-box block that makes 15.
And what does that tell us?
I know the sum of 4, 1 and 4, 2 is 5. But I can't narrow down the numbers any more than that.
What should we do now?
I did look at the 3-box block that makes 11. But I think there are just too many ways to make 11 with 3 numbers.
How many ways are there?
There's 1 plus 2 plus 8, and 1 plus 3 plus 7. Oh, wait. I can't use 8 and 7. We can only use 1, 2, 3, and 4 to make 11. That definitely narrows it down, but
try making 11.
1 plus 2 plus 3 is only 6, and 2 plus 3 plus 4 is 9. Huh? I can't make 11.
Are you sure you can't?
Even if I add the biggest numbers 4, 3, and 2. It still doesn't make 11.
Do the numbers have to be all different?
The block is an L shape. It's okay to use the same number twice.
Why is that okay?
Because those 3 boxes aren't in the same line. So it's fine if a number repeats.
Then, can you figure out which 3 numbers make 11?
4 plus 4 plus 3 is 11.
Are there any other ways to make it?
Nope, no other ways. It has to be 4, 4, and 3.
Looking at 4, 4, and 3, do you know exactly where any of them go?
Oh, I know where all 3 go. Since the 2 4s can't be in the same line, I have to put the 3 in 1, 1. Then the 4s go in the other 2 boxes so they don't make a duplicate.
The child utilized a unique combination and duplicate avoidance to finalize all 3 boxes simultaneously. This is the moment where previously learned strategies seamlessly integrate. You filled in the whole block at once! How did you do that?
To make 11 with 3 numbers, I had to use 4 twice. And since the same number can't be in the same line, I knew exactly where they had to go.
What is the next clue?
The 3 boxes make 4. That's a really small number to make with 3 boxes. Since 1 plus 1 plus 1 is already 3, the only way to make 4 is 1 plus 1 plus 2.
You used 1 twice. What does that mean?
It means we can't put the ones in the same row or column, so we know exactly where they go.
Let's put them in.
I'll put 1 in 2, 2 and 3, 1, and put 2 in the last box, 3, 2. Filling all 3 boxes at once is so much fun.
Pause for a moment to let the child compare the 2 blocks. Both the block that makes 11 and the block that makes 4 were filled instantly. Encourage the child to articulate the commonality that made this possible. The block that makes 11 and the block that makes 4, you were able to fill both of them all at once. Can you tell me what they have in common?
There's only one way to make that number. And because the same number goes in twice, we know exactly where they belong.
But just because there's only one way to make the sum doesn't always mean you know exactly where the numbers go. For example, the only way to make 3 is 1 plus 2. But we don't know right away if the order is 1, 2 or 2, 1. What else do we need to lock in their places all at once?
Having 2 of the same number is really important. We have to put them in different rows and columns, so we know exactly where they go.
But for the same number to go in twice, what shape does the block need to be?
It has to be an L-shaped block. A straight block is in a single line, so the same number can't go in twice.
That's right. When we can fill the entire block all at once, just by looking at its shape and sum without any other clues, we'll call this a sure block. Let's try solving the next problem.
Huh? There are no sure blocks that make 11 or 4 with 3 boxes.
Are there any other clues?
Oh, wait. There's a block in column 4 connected to 3, 3. I can figure out 3, 3. If I look at the 5 boxes that make 13, and take away the 10 from column 4, it's 13 minus 10. So it's 3.
And then what?
There are no sure blocks. There is a 3-box block with a sum of 10. But there's probably more than one way to make 10, right?
Why don't you check how many ways there are?
10 can be 4 plus 2, or 4 plus 3.
What do you notice when you compare these two?
Both ways use 2 of the same number.
What does that mean?
It means we know exactly where they go.
Try put the numbers for both ways.
We do know where they go. But it's a bummer we have two choices this time.
Are you only going to look at this one block? Are you only going to look at this one block? Is the only prompt the teacher should give here. The child must independently realize they need to look at the surroundings and recognize the impact of 3, 3.
Ah, I forgot that 3, 3 is already a 3. So 4 plus 3 doesn't work.
Why not?
Because it makes a duplicate with a 3 in 3, 3.
So, can you fill this whole block all at once?
Yes. I can fill in 2, 4, and 4 all at once.
Even though it wasn't a perfect sure block at first, you were still able to fill it all at once. How did you do that?
Because I looked at the neighboring box, 3, 3. Once I figured out 3, 3, there was only one way left to make the number.
The child has articulated the core concept independently. If you wish to highlight that they initially focused only on a single block without considering its relationship to surrounding boxes, ask, why did it look like there were 2 possible ways at first? When you first looked at it, why did you think there were 2 possible ways?
Because I only looked at that one block, and I didn't check how it was connected to the boxes around it.
Shall we look for more boxes we can figure out next?
I can fill the block that makes 4. 4 is 1 plus 3. But since 3, 3 is already a 3, I'll put 3 in 4, 2. And 1 in 4, 3. So they don't make a duplicate.
Take your time and see if you can figure out the remaining boxes too. Prompt the child with, "Did you learn anything new today?" to encourage self-reflection. Listen to their response, and if anything is omitted, use guiding questions to help them recall. The teacher should avoid summarizing first. Did you learn anything new today?
A sure block.
If you were going to explain what that means to a friend, what would you say?
It means we can use the same number twice in one block.
Can you just put the same number anywhere?
Only when it's an L-shaped block, not a straight one. We just have to make sure the same numbers aren't in the same line. That tells us exactly where they go right away.
Can you give me an example?
Like a 3-box L-shaped block that makes 11, or 4.